well, thank you very much for coming. And I know a lot of you have given me your time and your money and your attention, and I'm very grateful for that. It's got us to where we are now, and we'll go down out, and you can see outside where we are and how we're ready to go to market with this product. Just a little bit about the company. We incorporated in late 2019, and this was really as a result of the floods that we had in May of that year. And I spent 3 days out at Constance Bay filling sandbags along with hundreds, if not thousands of other people, because not only did we have that to tend to, but we also had Britannia Bay was flooding, it was about to take out our water treatment plant, hydro stations were being affected. And the important thing about that is that affects our complete way of life. If any of these critical infrastructure sites go down, it's not just that site and the people that work there that's affected, it's hundreds of thousands of people that live in the area. Those of you who remember when we had the blackout, remember when the whole eastern seaboard went down, we couldn't get gas, you couldn't use an ATM, fuel wasn't being distributed. Things just didn't work because we had lost part of our critical infrastructure. And that's why it's very, very important to protect and defend that. And we've seen the need during this pandemic for stockpiling protective equipment so that we're ready to react very, very quickly and to make sure that we can deploy resources on the ground effectively, both from a resource perspective, but also from a financial perspective. So when I looked at this, I was lucky enough that I'd experienced work with some very advanced materials technology. And over recent years, that technology's come on to a point where we can now use things like fabric tubes with a special weave and a special coating. We can inflate them up to 50, 60 PSI, so they're stronger than your car tire. And that's the type of technology that we've brought that together some very innovative textile production techniques. We brought all that together and come up with an idea that allows us to put up very robust, very effective flood defense barriers using 6 to 8 people and putting up a 7-meter barrier in under an hour. And I think you can see just from that the cost savings that we get, the labor savings that we're going to get. We're easier to store, it's easier to set up and easier to tear down. And it's extremely effective, and we've had that independently verified, and I'll show you some of the results of that independent verification later. More importantly, we've seen a tremendous amount of job loss in recent months. And it sounds odd starting up a company in the middle of a pandemic and all that involves, but it's done 2 things. One, it's made some financial resources available to us from the government that previously were a little challenging to obtain for a company in our stage of development. And also it's shown the need that not everybody writes software code, not everybody's a code warrior, not everybody has a degree in an advanced science subject. That we have ordinary people that need to get back to work, so they need to feed their families, they need to pay their rent. And that also is one of the driving forces behind what I want to do. We're going to have 50 to 70 really good, well-paid, sustainable, blue-collar and middle management jobs. And I'm very passionate about that. We're going to have very good employment standards, and it's something that is very important to me. Equally important is there a market out there? Are we going to sell these? Well, we did our analysis. We found that there's about over $200 million worth of demand for flood defense systems. We've got a range of high performance, rapidly deployable flood defense barriers. They're affordable, they're reliable, they're durable, and more importantly, you can use them over and over again. They're not a one-shot device like sandbags are. These can be put up, used, taken down, stored, and then used again and again and again. There we've built up a cross-section of one that would show how many sandbags are required just to reach the height of the wall that we go to. And trust me, it is very, very significant. In our recent trials, recent validation testing at the NRC, the barriers we set up in about 10 labor hours using 58 sandbags would have taken over 60 labor hours and almost 1,000 sandbags to build the equivalent walls. The great thing about these is you need to get them on site, and hauling sandbags across terrain that's probably muddy, boggy, wet, uncomfortable is going to be, poses tremendous risk just in the fact that you're going to take a truck out there and it might get bogged down. You've got to move these things, you've got to have large numbers of people to move these around. We can fit 2 of our barriers in the back of an F-150, just to put it in terms of, everybody understands, everybody knows how big an F-150 is. 2 7-meter barriers in the back of an F-150. And all of the barriers can be handled by 2 to 4 people. Every component can be handled by 2 to 4 people. So we've designed it so that it's lightweight, easily handled, but with the technology we have, it's durable enough to stand what could be about 18,000 pounds force of water pushing at the bottom of the barrier. Our objective is saving lives, livelihoods, and saving a heck of a lot of money. So what is the problem? Well, there's the government's done numerous studies, and you can see from the that little text box in the top right there. We need to take preventative and mitigation measures, and it does produce a return on investment. And that's not just from the government financial people. Insurance companies have consistently come up with figures between, for every dollar spent on preventative measures will save you $5 to $8 in recovery costs. So there's a tremendous return on investment from that. And the reality is flooding is becoming the new norm. The 1 in 100-year flood seems to be occurring annually now. So that particular metric's gone out the window. They're not seasonal anymore. It used to be snow falls, snow melts, flood. With climate change, it's very, very unpredictable. And we're seeing virtually every week, you see on the news, some country, some location is flooded. So it is a global problem, and we're spending billions of dollars every year in recovery and repair efforts. In some places, it's even impossible to get flood insurance. And I know that the insurance industry is working very hard to try to understand how they address that. That really does need attention, it needs protection, because if we did lose any of our critical infrastructure, it's going to cause damage beyond the immediate location of the flood. So we're looking at things like power, water treatment plants, chemical plants, highways, fuel depots. Any of those get taken out, our standard of life is very adversely affected. And the recovery and repair costs are going up all the time. I'll show you in the next slide. They're spending billions of dollars a year on recovering from these things. There aren't any really innovative solutions for the short and the medium term. In the longer term, we're looking at things like property buybacks, floodplain management, different ways of actually building cities from scratch, smart cities, those sorts of things, where you need to design into the infrastructure a way of keeping flood water out. We've seen they've done a great job with earthquakes on designing earthquake-proof buildings. Now we're turning more and more towards flood-proof buildings. The current infrastructure solutions are many years away from bearing fruit, if you like. What we have here is we have a solution that is available now, and it can be implemented now. And it means that governments can stockpile protective equipment now. And particularly with COVID-19, we're not going to be able to get those huge crowds of people coming around. People won't be prepared to take the risk, not only for filling the sandbags, but also the very onerous task of removing them. Once the sandbags are contaminated with all sorts of waste and heavy metals and things that always occur during a flood, they have to be specially disposed of. And again, that costs a significant amount of money. Moving assets across the country, that could well be effective. We've seen our border continually closed. We've seen inter-provincial restrictions put in place. And it could seriously hamper the ability to move any of these assets around the country. So on a provincial basis, every province needs to be prepared. And the large amounts of post-recovery flood funding that we had, well, you know what? A lot of that is, and rightly so, is going towards, pandemic prevention and pandemic remediation. So they're just there's just not going to be that money available. So we need to find a much more cost-effective and much more reliable alternative. There are some pictures there, and you'll be familiar with some of those. The troops we had to bring in to shore up the little road that leads to the Mud Lake water treatment plant. Because if that flooded, they couldn't move the chemicals in or out. So that plant would have ceased to function. And that provides over half of Ottawa with its water. But there's the Canadian forces, great though they are, a limited resource, and the Chief of Defence Staff, General John Vance, said last year that he just cannot sustain support to civil governments and support for military operations. It's just completely unsustainable. And it's also hugely expensive, 800 troops for 2 weeks, over $1.5 million. And that's just in labour costs alone. So there's a significant amount of money being spent there that could be redirected elsewhere. Over 10 years, they spent $445 billion, so average of $4.5 billion a year on flood recovery costs. So what we've got here is we've got a very, very new approach that that is aimed at saving lives, is aimed at saving livelihoods and saving a huge amount of money. You can read the bullets there, but what I do want to bring out is just how very simple this is to put up and take down. So what I've got here is I've got some elements from what we call our 3-stage setup. So the first stage we set up is we drive our front support posts into the ground. They're anchored solidly into the ground, either with wedge anchors, concrete anchors, or stakes if you're on soft ground. You drape the barrier over those, you put these support tubes in, you then bolt them so that everything is being secured to the ground. It's all about getting this downward pressure to anchor everything to the ground. And then what we do is you inflate the barriers, we put in our collars. Again, that's holding each individual barrier is held down and bolted to the support tubes. And there's the inflated design. So that in that particular stage there, we can have up to 3 foot of water. We'll hold that back. We've had waves of up to 1 foot being thrown at this, so you can imagine the constant pounding of those waves, and those barriers remained up. What we've got here is what we call our extreme weather extension kit. So that's a bracing strut and some rear plates, and that does 2 things. If you've got if you're expecting above 3 foot of water, you put the bracing strut in. But also, it's quite important because, generally speaking, flooding is preceded by or accompanied by a storm, and those have strong winds. So at the moment we're going to be doing some further testing, but at the moment we know that will take up to 60 mile an hour winds. So we're looking at 60 mile an hour. So we're looking at well over 80 kilometer per hour winds. So a team of 6 to 8 people, and I've had trained and untrained people. 6 to 8 trained people can put these barriers up in well under an hour. Untrained people, it might take you 90 minutes. But even so, that's still a significant time saving. Does it work? Is the big question. Well, we did some final in-house product qualification testing, and we connected a 7 meter and a 3.5 meter barrier together, and you'll see those outside when we go out to the demo area. And then what we did is we fired high pressure jets of water at it, and we filled it to a height we had about just almost a meter of water in there. And you can see very little seepage from the outside. Now you see a row of sandbags along there. The reason for that is because we have front and back aprons. And what we need to do is to keep those anchored to ground until the level of the water is built up such that the force of the water itself will keep the aprons down. And also provides you obviously with a little bit of extra protection against seepage. But again, that's going to 58 sandbags for a 7 meter, 7 and 3.5 meter barriers connected together, as opposed to over 960. So it's very, very effective. And then what we did was we then went on to, we wanted to know just exactly how good these barriers were and what forces we were actually dealing with. So we contacted NRC, and we were very grateful to be accepted into the IRAP program, Industrial Research Assistance program. And that enabled us to do some very, very cost-effective tests. The coastal water basin on Montreal Road. And that is essentially, it's a honking big wave pool. And you can put various structures and devices in there, and you can throw all sorts of waves at them. And what we did was we wired the barrier up with monitors. They were wired up with sensors, so we were looking at all types of pressures, both coming into the face of the barrier, on the bracing struts, turning moments on the posts that were anchored into the ground, and so on and so forth. And I think you can see this, and this is one of the things I found most impressive, was you can see across the top layer of pictures there, steady filling it up. We were almost up at the top of the barrier because we also had to push waves at it, and we didn't want it sloshing all over the top. But we're right at the top of the barrier. You can see those pictures at the bottom on the left and the right there. There's hardly any water on the dry side. And that proved that these did what they were designed to do, which is to slow the flow of water such that it can just be handled by a simple sump pump. And what you're seeing there is a $25 sump pump from Canadian Tire. And it kept that area well below an inch of water in there. And it was very, very easily done. And again, you can see highlighted there, the barriers are set up under 12 labor hours, 58 sandbags, in what would have normally taken well over 60 labor hours and 900 bags. And again, you'll be able to see a cross section of the wall equivalent that we've put outside. Now there are other systems out there, and they do their job. I mean, just look at this. There's three basic types of systems. There's sandbags, there's water-filled barriers, and some of you might remember from the 2019 flood. And they do a very good job. The disadvantage we found with those, and what we've overcome with our system, is that you have to fill them with water. They have to be filled with high pressure water. You can't gravity feed these. So you're either talking about a very local fire hydrant that's nearby, or having water pumps. You need to have a supply of water. Well, yes, you're protected against a flood. Yes, there's a lot of water. But you know what? That water is heavily contaminated. There's animal waste, human waste, heavy metals, all sorts of stuff floating around in those. And when you put them inside these structures, they become a health hazard. You then have to thoroughly disinfect them before you put them away, inside and out. Ours, you can scrub them down with bleach or some sort of disinfectant, let them dry out, roll them up and put them away. And there's just some statistics there where we've looked at various attributes of these systems, ranging from the time to set up, the time to dismantle, durability, reusability, and so on and so forth. We also looked at the cost of ownership, and I think this is very important because if you look at sandbags, they're actually the most expensive way of doing it. Although it's just a simple sandbag, it's a burlap sack, and you fill it with sand and you tie it up and chuck it on the ground where you need it to be. It's as I said, it's a one-shot device. You can only use it once, and then you have to do the same thing again. So when you look at it over multiple flood events, in this instance we looked over 4 flood events because that's a typical annual cycle. 2 at the peak times and 2 during the year. It's over $35,000 to cover 4 flood events. We've looked at the water-filled barriers, and they're typically in the $11,000 to $12,000 to $13,000 range, and ours are around $11,000 for the equivalent. But then you use it again and again and again. So the cost of ownership becomes very, very low compared to sandbags and compared to some of the other barriers. We could put these in, and once you've taken them out, you never knew they were there. It's very much cleaner, greener, and safer.
Is there any special equipment needed to install them?
No, it's very simple. A small air compressor and an impact wrench, hammer drill, just common hand tools that most organisations, municipalities and provinces have within their maintenance departments. One of the evolutions of the company is going to be into managed services. So what we would do is customers would purchase the system, and then when they need it put up, we would send a team out who will put it up, and then they'll take it down, clean it off. They can store it, we could offer a storage service. It all depends on the business case for that, but absolutely offering, that is in our plans later downstream, offer a managed service where we'll come and put the barriers up and take them down for you. Well, let's go and have a look at some barriers then.
Let's go have a look.
See what Dan's done.